We are very glad today to receive Mr. Mathew, and he is the head of Iota. Iota, it's a new infrastructure system, okay, that we can arrange new possibilities for all the automotive industry. Just only for a short introduction here, IoT and digital automotive services are centered and nowadays still empowering consumers and bringing improvement for the mobility and giving new challenges for all the automotive industry. IoT brings all the time economic value with the new IoT technology, and markets will be forever altered. Nowadays, with a world where the future is far for the certain real example what we are living today, the technology speed up new opportunities. So the automotive companies will need to develop new core capabilities to survive with the new automotive digital twin and the new improvements with connected vehicles, infrastructure, technology, and finding knowledge and existing resources for all the electric mobility and the autonomous vehicles. We don't know what the future will look like, but organizations using new IT capabilities are better positioned to grab a larger slice of the applied technology value. So there is opportunity today for all the automotive ecosystem to be a disruptor and companies taking part of Iota ecosystem and solutions too. So thank you, Matt. You're still with us, and now we are going to describe more about of these great possibilities that we have inside the Iota ecosystem.
Thank you. Yeah, so hi everyone. I'm Mathew Yarger. I am head of automotive and mobility at the Iota Foundation. It's happy to be here. I'm happy to present to all of you today and talk to you a little bit about decentralization, open source technologies, and where all these things kind of come together to solve problems when it comes to IoT, automotive, mobility, smart cities, and so on. So let me go ahead and try to share my screen here. All right. Can you see that?
Sure.
All right, ready to go then. Okay, so for a little bit of background about the Iota Foundation, we're a relatively young foundation. We were founded in 2017, and I've been part of the foundation almost since inception. I came to the foundation from the U.S. federal government. So for everyone who's not aware, I'm based in the U.S. I'm based out of Austin, Texas, which is a very big mobility hub here in the U.S. as well. And we're working with companies like Jaguar Land Rover and a number of others in cities like Austin itself to test out transportation infrastructure, smart mobility, and really understand the future of where all these technologies are going. I come from a pretty diverse background. I was U.S. federal government beforehand. I did cybersecurity, cyber operations planning, and digital forensics for the National Security Agency and the Department of Defense for about 10 years before I came to the foundation. In that capacity, I really started to research how can we change the systems that we interact with and the data that we use. Because when it comes to creating these solutions at scale, vehicles connect at the edge of infrastructure all the way out where 4G and IoT gateways and roadside units and all these kinds of things are really relevant. But those ecosystems are very fragmented, and vehicles are a very mobile use case for IoT, of course. So there's no way for one solution to really own all of that space. And that's one thing we're seeing now with Zero Trust and a number of other things. But I'm excited to see where we're coming and where we're going with this technology. And as I did my research, I looked at a lot of different comparing technologies. And to me, Iota really offered the core of what's necessary when it comes to transparency, security, real-time data, very predictable network costs because there are no fees in our infrastructure. And that's really been the root of what we're trying to accomplish as a foundation. Not just in mobility, but also in supply chains and energy infrastructure and telecommunications, smart cities, healthcare, and a number of other verticals as well. But I predominantly focus on infrastructure, transportation, and smart cities. So we have a very large ecosystem. These numbers are last year's numbers. We're about to do a really big network upgrade this year, and we're going to refresh all these numbers. We've seen a lot of growth of the technology in the last 12 months. So as you can see here, we work with a lot of really great organizations on the open source side, on the standardization side, on the regulatory side, and in the automotive sector, among other areas. We have a very large open source ecosystem and community as well. They're very loud. They love to, tell the benefit of what these technologies really offer and showcase it and innovate with it. We're building a lot of great things with Jaguar Land Rover, Dell Technologies, Trademark East Africa, Zebra Technologies, and a number of others, some of which I can talk about shortly today. Big question though is, why do DLTs even really matter? So when it comes to these fragmented ecosystems, the ability for organizations to come together and share information with each other in a way that's trusted and common between them has traditionally been really difficult. It's hard to be able to share information directly from devices or from systems with organizations you're collaborating with. It's hard to do that in a way to where they can trust that the data hasn't been manipulated. And it's harder to do that in a way to where, regardless of the infrastructure you're connecting to, it has a level of interoperability, whether you're running in Texas, whether you're running in Brazil, or whether you're running in Berlin. You need a common framework to be able to start to share this data. And OEMs have been looking into this sector for how to unite what they're doing and share with each other and share with other stakeholders, whether it's transportation infrastructure providers, IoT sensor producers, or a number of others that are active in this space. The key capabilities that really allow that to happen is this permissionless ecosystem. And what that means is anybody can participate. There's not a barrier for you to come in and build with these technologies. They're all open sourced. You can go and download them and build your own solutions tomorrow and start to solve real problems today. And then taking that out and being able to connect with each other without needing a mediator or a third party to facilitate all of that is where the growth in this ecosystem and these technologies really happen. And then one key aspect with the Iota side too is this payment capability, because as you expand into different markets, you also need to be able to facilitate payments between devices, whether it's a vehicle paying for tolling or roadside parking or access to a parking garage, or whether it's ordering a Starbucks from your car and being able to pay seamlessly between it in the future. These are all things that are currently being tested and piloted in various capacities by various partners in different markets. With Iota, we're really aiming to become this trust protocol. We've designed Iota to alleviate a lot of the concerns that limit traditional blockchain solutions from coming into these edge-focused sectors. And we chose the name Iota because it represents the smallest piece of something. And when it comes to IoT, the ability to take something small like a single data packet and then produce an insight and make a decision based off of that is really the benefit of what IoT is generating in the first place. But we need to be able to do this in a way that's secure, that's trustable, that's verifiable, and that we can all really start to accelerate the level of collaboration we have and the type of innovation we're creating. If you look on the right side, you can see a top image with a few blocks that are connected with a line. That's traditionally how you can simplistically view a blockchain. It's a sequential list of blocks for those that aren't common or haven't been familiar with the concepts. On the bottom, that's what our architecture looks like. So you can see it's very different than a traditional blockchain, but it's built on the same principles. And those principles are, how do we build something that goes into a distributed system? IoT is the maximally distributed system there is. How can we do so in a way to where consensus or a common understanding can be automated? We take mathematical proofs and traditional math and computer science concepts, and we integrated that into this distributed system structure. But then how can you create trust? And trust is really taking something over time and proving it consistently. And that's where immutability comes into play, or tamper-resistant data. So when you take data from a device and you spread it out to 100,000 different devices, and you can have 100% certainty that every one of those devices has the same data, that gives you a level of trust in the data that you didn't traditionally have before. You can have assurance that the data hasn't been manipulated because you can actually go verify it. And when it comes to building solutions off of trusted data, that completely changes the way your systems operate. If you look at existing IoT systems, I believe the number is over 90% of IoT solutions are still using unencrypted communication. So the data that your devices are sending to your network is open. Anybody can capture it, anybody can read it, anybody can see what kind of data you're collecting and what data you're sending to your systems. So you need a common protocol that can start to solve these problems, that can secure your data, and that can allow you to share it with your stakeholders and your partners in a way that they can trust you as an individual, or you as an organization, or you as in the solutions that you're providing. These technologies really help to do that. One key differentiator as well between us and traditional blockchains is with a traditional blockchain, you have to send value to send data. You can't just send data. We see that as a very limiting factor to the growth of these technologies in edge environments like what IoT demands. You need to be able to send 1,000 different pieces of data that generate an insight that can help you make a decision. And then that decision can be where the value transfer happens, whether it's a service or whether it's you paying for transfer of goods or anything along that nature. When that decision happens, that's when the value transfer can happen. And it doesn't mean the value transfer has to happen with every decision, but having the flexibility to transfer value between devices or organizations or nation states even in a very seamless, open and transparent way when there's a need to do it, but having the data on the back end to bolster the need for that in the first place is really how you do more with a blockchain solution than just send value from one individual to another or one device to another. This is a live capture of what our network actually looks like. So as you can see on the right, it's very organic. There's a lot of movement going on there. This is still only about 300 to 400 transactions a second. We've well eclipsed this, but this is just a really great graphic to help understand what data and value moving together can look like over a network. So as you can see, there's a lot of organic structures in there, and we try to really tailor everything to have organic principles. But in line with that, when it comes to integrating these solutions at the edge, there's a, when it comes to integrating these solutions at the edge, there's a few requirements that come into place. One is you have to have absolutely minimal energy requirements. And with us, a single transaction costs 1.18 millijoules. So the number of transactions you can send for the electrical cost of 1 US cent is extremely high. I believe the estimations are around 180,000 transactions for 1 cent in energy cost. And that's a lot of data and a lot of value that you can transfer between systems operating at the edge. It also has to be very scalable. Our confirmation times are sub 5 seconds or 10 seconds. We're progressively working to get those lower and lower. So that's going to be a big requirement to enable machines to communicate together in an automotive context or in a supply chain context. We also think that there can't be any fees between these devices for them to communicate, and that's going back to that sending data or value. With other blockchains, you have to pay a fee to send that data, and the amount of data you're sending is very minimal. With us, there are no fees built into the blockchain. Because we have this organic structure, you can send as much information as you want, and it continues to make the architecture and the system as a whole faster up to a certain extent. So that gives a lot lower barrier to entry for solving these problems in IoT and actually getting a lot of benefit from how you gather your data, how you secure your data, and how you share your data. To go briefly into mobility, this is the transition that we're starting to see in the industry. OEMs, like vehicle producers, design a car, they build a car, they sell a car, they repeat. That's their process. You can add a few packages here or there. You might design once, but you still have to build a physical car and sell that physical car one time. Recapturing that value is extremely difficult. Now that we have these decentralized technologies that can integrate into vehicles, infrastructure, and so on, capturing that value multiple times after you sell a vehicle becomes very feasible and very efficient. So you can implement services based on data in a vehicle, whether that's the vehicle capturing something with a computer vision system and selling that data on a marketplace, or providing it to a public transit authority so that they can respond to events in a more timely, proactive manner. So the transition that we're starting to have now that we have this level of trust and serviceability at the edge is we can start to tailor these digital solutions that happen directly in vehicles, but we can do it in a way that has trust and security at its core. So you're not taking advantage of drivers, you're not taking advantage of other organizations. They can trust the data that they're providing is being used appropriately. They have the option in a GDPR, General Data Privacy Regulation perspective, to revoke the access to that data as well. So having the option to do this and building services around it allows for a completely different revenue model to happen with traditional companies. And the innovation we're going to see because of that can't even be predicted in a lot of ways right now. So we're very excited to see how it continues to grow. One example of this I like to structure out is there's really 4 kinds of data. There's your private data as an individual. When you buy a vehicle, you have data that's produced about you. You should have the right to say who gets access to that data, and you should get a share of what happens when that data is accessed. If you're making your data available, you should be incentivized to do that appropriately, whether that's giving data to your local authority so that they can make better roadside infrastructure, so that they understand the ebb and flow of transportation, so that they understand when there's accidents or bad roadside conditions so they can be more proactive with maintenance. You should get an incentive for that. This starts to outline how that happens, whether it's reduction in taxes, whether it's free public transit, whether it's free public Wi-Fi, or a number of other things that start to happen, like reducing your utility cost or other things. These things can start to happen once the individual has control of their data and they have the option of supplying that. And then the cities can be consumers of individual data and then build solutions based on what their citizens actually need. There's also other types of data like product data. The OEM, say Jaguar, Land Rover, Mercedes, Ford, whoever is your preferred OEM, should be getting product data, but they should only be getting product data. They shouldn't be pulling my location at a specific time of day and knowing where I'm at and what I'm doing. That's a violation of my privacy from my perspective, and I'm sure many of you would agree with me on that. So the ability for them to get their data and only their data, and for me as a vehicle owner to verify that's the data they're getting and no more, is something that should happen, because I want Jaguar or Mercedes or whomever to be able to build better products. When I go buy a new car in a few years, I want to be able to understand the impact that I've made on the products that I'm buying and know that they're being built in a better way because of the kind of data I'm providing willingly. There's also other types of data like public data, where this environmental conditions or roadside conditions or accidents or things of that nature need to be reported openly to public entities like local authorities so that they can respond appropriately. And that has a different type of incentivization measure. And then once you get all these things coming together, the ability to build services from third parties as well, whether that's your Starbucks or your McDonald's or whoever your favorite vendor is that you drive by on your way to work or on your way home, being able to access services directly from them in a way that's not advertising heavy, but very in your control, is something that starts to become available. So everybody can start to benefit from this decentralized service capability in a very open way. We just have to continue to innovate and be transparent about what this looks like, what the standards are around it, and how we utilize it appropriately. One interesting aspect around the Iota side as well is we have a unique ability, because of how lightweight we are, to integrate at every point along where data comes together. So one of the things we've done with Dell and Intel is we've started to integrate what's known as Project Alvarium, which is the creation of a data confidence fabric. To do this, you have to be able to have oversight of data at every piece of the network, whether it's a roadside unit or gateway or some degree of connected infrastructure, if it's an edge server or a local micro data center, whether it's a larger data center or a cloud instance, or whether it's directly in the vehicle or in a mobile device. You need to be able to integrate a lightweight application that can start to have access to this data and provide oversight in a compliance perspective. And the ability of Iota to do that, because of this zero fee structure, because of its energy efficiency, and because of how lightweight and near real time it operates in, is very unique in this space. So we can put a node or an entry point to taking data from a vehicle, from a gateway, from an edge server, or from the cloud, and supplying them autonomously through this infrastructure. It's sort of like a smart mesh, if you will, in a very open way. This also alleviates a lot of interesting problems, such as vendor lock-in. You're not necessarily tied down to one cloud provider if you can take your data and shotgun it out to 4 different clouds at once. Doing this in a very verifiable and tamper-proof way, with that immutability and that consensus built in, allows you to have confidence that the data that's on your Azure cloud is also on your AWS cloud. So then you know that what's there is there, and you have more of a standing to be able to discuss or work with the cloud providers more proactively. Your data is no longer locked into a single cloud. You have more control over what happens to it. And if you don't like what's happening to it, you have more control to take that access away. And then this, of course, starts to bridge into other ecosystems because infrastructure isn't siloed. Roadside infrastructure does connect to energy infrastructure. Electric vehicles are advancing extremely quickly. So the ability for a normal vehicle and an electric vehicle to have this common protocol that can allow differentiated services is really what we're going to start to see in the future. Electric vehicles paying for energy on their own, you having a preloaded wallet directly in your vehicle to pay energy infrastructure, to pay tolling, to pay in a smart grid type of way for different types of services is what's going to start happening over the next 5 years. There are existing standards that are being built in this space. MOBI is doing an excellent job, MOBI being the Mobility Open Blockchain Initiative, bringing together different OEMs in the mobility space, whether that's tier 1 suppliers, system integrators, OEMs, or other, and being able to say what kind of data attributes are important, how do we standardize that, and then how do we have confidence around it. So 2 really important standards around how to do this are the VID standards, which is essentially standardizing a digital identity for vehicles. It takes things like the vehicle identification number and different aspects of the vehicle and allows you to provide access to that data in a very readily available way, but in a very secure and transparent way. And it also allows you to take access away from that data to the different individuals or organizations you're providing it to. The ability to build services on top of that, once that's in place, is really pivotal to opening up the ecosystem and creating a lot of these new service capabilities at the edge. Another that's more EV specific is the EVGI standard, the electric vehicle to grid integration standard. So this is more around the future of business capabilities when it comes to IoT and mobility. How do we get a statement of health on your battery usage? How do we understand the state of charge? How do we get diagnostics? And how can we be sure that none of this data has been tampered with? Because as we're seeing with the future of electric vehicles and the business practices that come around that, we're going to want to be able to recycle these batteries, take them and put them into other instances and use them for different purposes. But to do that, we need to have confidence in what we're buying. And that's really hard to do when it's coming from such a fragmented ecosystem as mobility and when the OEMs don't have ownership of the batteries after the vehicle's sold. With these kind of capabilities, we can start to provide that level of confidence and transparency around a system such as a battery system in a vehicle. And when it starts to expire from use in a vehicle, it can be repurposed for multiple other things. We've got quite a few case studies that we've done in the space. One really exciting one that was just announced in the last 2 months is Project Alfred. So one of our partners, Ito Gruppe, has been funded by the German federal government for developing roadside infrastructure for using decentralized technologies based on Iota, allowing connected and autonomous vehicles to have more resilient, verifiable, and open ways of communicating with each other. We've also done a lot with Jaguar Land Rover around energy provenance and traceability. We've done work with Elad NL where you can integrate a wallet directly into a vehicle and into a charging station and pay in the native asset of Iota, which is the Iota token, for that charging capacity. And then we also have tested out computer vision capabilities. Well, they have tested out specifically. We didn't work hand on that project with them. And tolling infrastructure capabilities. And that's where they really see smart wallets and smart integrations of these decentralized technologies going. And then as I had mentioned previously, we were working with Dell and Intel on Project Alvarium. We're currently working on open sourcing Project Alvarium to the Linux Foundation. So those discussions are ongoing and we should have more updates on that. And then we're working with a very large consortium, the City Exchange Consortium, which is another EU Horizon 2020 funded project to do decentralized energy infrastructure. And where electric vehicles integrate with that is a big piece of what they're trying to accomplish, as well as allowing one home to supply energy to the home next to it, or one block to the block next to it, or one city to the city next to it. And that is my presentation. I am open for questions.
Sure, Mathew. I have one question for you. It's Alexander here. In terms of APIs, what is the great challenge or what is disruptive situation using Iota? That's a practical use case that you have with the APIs and the connection with all the ecosystem and the automotive industry connection.
Can you rephrase that question a little bit?
No, about the APIs, the integration with the APIs, okay? What is disruptive in terms of use Iota to exchange these APIs? That's my question.
Okay, so I mean, one thing about our APIs is, of course, our entire technology stack is open source. Our APIs are open sourced, and everything that we're working on in that space is working towards standardization. One of the capabilities is known as Iota Streams. It's our data compartmentalization tool, and that's going through standardization with the object management group right now. But what's highly disruptive in that space for IoT and automotive is the ability for the devices and the individuals that directly own those devices to have full control over what happens to their data and where it goes. You can now start to compartmentalize or packetize your data and put it on this decentralized network. And there's no IP association with that data packet anymore. It's just on the network. So you can start to offer that through subscriber models and different capabilities so that there's a marketplace or service type concept that's happening with your data. Whether that's an individual that owns a vehicle that's bought it and they want to provide that private data onto a marketplace or to their city, or you want to share data between one of your partner organizations without giving them access to your cloud. This gives you the capability to start to make those connections and share that data very openly and very efficiently. That's a very disruptive technique.
And Mathew, the second question, what do you think about the Iota integration with AWS and Microsoft and other ecosystems that provide all the situation to store the information, and all the automobile industry still using of this AWS Automotive and other ecosystems? What you can see in the next 5 years that it's going to be with this situation?
So I think traditionally we go through these phases of centralization and decentralization, and that's really required for innovation. And what we're seeing with AWS and Azure and the growth of cloud is these cloud native applications to where everything is sending the data to the cloud, and then the applications that we're using are pulling data directly down from the cloud. But what we also see is that causes disruptions. You can see, I think it was 3 to 4 months ago, where Tesla owners got locked out of their vehicles for up to 2 hours because the cloud that supported the connection of their phones to their vehicles went down. So they could no longer get into their vehicles to drive home. So while there's a lot of benefit that comes from cloud use and the use cases where high levels of processing or analytics or data sharing or what have you are required, there's also problems that come from only being cloud native. So we're going to start to see this transition from cloud native back to this more decentralized local instance, or this on-prem instance, where machine learning and things of that nature are taking data and they're processing it directly on the vehicle. They're sharing it locally instead of it necessarily needing to go to the cloud, and you're able to have more resilient services and capabilities because they're edge native now and not just cloud native.
That's amazing, Phil. That's amazing.